Today our goal is to solve quadratic equations with complex solutions. Yesterday's lesson may have felt like we took a deviation from solving equations to talk about complex numbers, but here we see complex numbers coming back again, right? We're still solving, meaning looking for solutions or values that make the equations true. We're still solving quadratic equations. Those are equations in the form ax squared plus bx plus c equals 0. The difference today is that our solutions may be complex. That is, we may get values like x equals a plus bi. So let's dive right in. Our first example, we're solving an equation, x squared plus 4 equals 0. We learned a couple days ago it's usually faster to factor if it's possible. So let's think, are there any numbers that multiply by 4? Well, this is x squared plus 0x plus 4 is 0. So you'd want them to add up to 0. Well, the factors of 4 aren't going to add up to 0, so it can't be factored. Let's use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's substitute. I have a, the unwritten coefficient, 1, b is 0, c is positive 4. 0 is neither positive nor negative, so when you sub it in, you don't have to be worried about this negative b. This is exactly what we did a few days ago. We're going to simplify what's inside the radical by squaring and multiplying. We can drop the 0. Then we can continue to simplify what's inside of the radical. This is where today's lesson builds on yesterday's lesson. A square root of negative 16, well, you practiced last night. We can think of that as x equals the positive or negative square root of 16 times the square root of negative 1. We can break apart this negative 16 into its product, 16 times negative 1. When we do so, I'm sorry about that. When we do so, we see the square root of negative 1 coming back up. This is our friend I. So we can just substitute for I and evaluate the square root of 16 we know to be 4. So this is x equals positive or negative 4i over 2, or 2i and negative 2i. Here are our complex solutions. They're in the form 0 plus or minus 2i, so that a plus bi format. Let's solve another equation. Recall that the factoring and the quadratic formula only work when your equation is set equal to 0. So let's start by getting all of the terms on one side of the equation. It's always fastest to factor, so let's try that out real quick. Are there numbers that multiply to 1 and add up to that middle term 2? Yeah, 1 and 1. So we'd have y plus 1 times y, I'm sorry about that, jumping ahead. We'd have y squared plus y plus 1 equals 0. Once we split this middle term 2y into y plus y. Take out what's common to both pairs. There's nothing in common to this pair, so we'll take out nothing, or 1. So we have y plus 1 times the quantity y plus 1 is 0. If two things multiply to 0, one of them individually must be 0. And so we have the solution negative 1 or negative 1. We got the same solution twice. Okay, let's look at a third example. This will be our final example of the day, since today's lesson simply builds on the last couple days' lessons. Let's get both terms on the same side of the equation. We want one side to be set equal to 0. Factoring is faster, so let's try it out. Multiples would be 1 and 26. Those aren't going to add to negative 6. 2 and 13. That won't work. Okay, factoring won't work. Let's use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Substitute. Make sure this square root goes all the way to the end of that product. Do what's inside the square root. Oops, I'm sorry about that. Jumping ahead here. Let's subtract. And again, we see that we've come up with a square root of a negative number. Anytime you have a square root of a negative number, split it up into a positive root times the square root of -1, because this is like leaving your answer kind of messy. This would be like when I grew up, after you ate dinner, my mom insisted you had to push your chair in at the dinner table. You don't want to leave the kitchen looking like a mess. In the same way, you don't leave a square root with a negative number inside. You want to split it into the square root of the positive number times the square root of -1, because we can substitute. The square root of -1 is our friend I. And finally, break apart this answer. Now, 6 over 2, of course, is 3. So go ahead and reduce. You can put them together if you'd like. So you have 3 plus or minus the square root of 68 over 2i. I comes out to the end, so it maintains that a plus bi, I is all the way at the end format. You are welcome to stop here. This is your final complete answer. Those of you that are practicing further reducing your roots will notice 68 is 4 times 17. So you can write x as 3 plus or minus square root of 4 times the square root of 17 all over 2i. This is handy because 4 is a perfect square. And you can reduce the fraction outside of the root. 2 over 2 is just 1. So you get x is 3 plus or minus 1 square root of 17i. Make sure it's clear I is outside of that root.